yesterday in our notes, we ended at the top of page 3, right? We've been sketching graphs of various polynomial functions. And we did A on the left yesterday, that's where we ended. And so now we'll do B on the right. So the polynomial function, right? So both of these functions in A and B are polynomials. Okay. The one in A is typical, called standard form. Okay. You can see that the leading term is x to the fourth, right? The degree of the polynomial is 4. The leading coefficient is 1. And this is a polynomial function, but it's factored. Okay. So this is sort of like standard form. This is factored form. Every polynomial function can be factored. Okay. All right. So I'm going to write it down. F of x is equal to negative. Okay. Now, this minus sign out front here, that's minus 1. Okay. The 1 is invisible. So I'm going to write it out. Right. That's minus 1 times x minus 4 cubed times x minus 3 times x plus 2 cubed times x plus 5 squared times x minus 1 squared. Okay. And so yesterday we talked about the multiplicity of zeros. Okay. The 0 can occur more than once. And so to find the zeros of this factored polynomial, right, we set the right-hand side equal to 0. And then we, using the zero product property, we set each factor equal to 0 and solve for x. Okay. So we'll set the right-hand side equal to 0, and then by the zero product property, now I have to admit there's not a whole lot of space to write. Okay. So, but I was able to, what I'm going to put on here, I was able to put down below the coordinate plane. And so the first factor is x minus 4 cubed. Right, so we set that equal to 0. The second factor is x minus 3. Actually, I can drop the parentheses. Because that x minus 3 is raised to the first power. Okay. And then we have x plus 2 cubed is equal to 0. And then we have x plus 5 squared is equal to 0. And then we have x minus 1 squared is equal to 0. And so when solving this equation for x, right, we take the cube root of both sides, and then we add 4 to both sides, and we get x is equal to 4. And you can see by inspection, you put 4 in for x here, you have 4 minus 4, which is 0, and 0 to the third power is 0. Solving the second equation, we get x equals 3. In solving the third equation, again, take cube root of both sides, subtract 2 from both sides, get x is equal to minus 2. In the fourth equation, take square root of both sides, subtract 5 from both sides, get x is equal to minus 5. And the last equation, take square root of both sides, add 1 to both sides, you get x equals 1. Okay. So these are the zeros, these 5 values of x are the zeros of our factored polynomial, right? To make the right-hand side equal to 0. Okay. They are also the locations of 5 x-intercepts in the graph of this polynomial function. Okay. So there's an x-intercept at each of these values of x in the graph of this polynomial function. Okay. All right. Now what I'm going to write, I put above up here, and we're going to list each zero and its multiplicity. So I created a little table up above the polynomial function. I listed each zero and its multiplicity. Okay. And I just went in the order listed here. So the zeros are 4, 3, minus 2, minus 5, and 1. And the multiplicity is equal to the exponent over here on the left-hand side. Because x minus 4 cubed is equal to x minus 4 times x minus 4 times x minus 4. And so there are 4 places, there are 3 places where I can put the number 4, and this product will equal 0. So we say x equals 4 is a 0 with multiplicity 3. Okay. And the multiplicity just turns out to be the exponent, okay, on the factor. And so x minus 3 here, right, has the divisible 1. Okay. And you can also get the multiplicities from the exponents up here on the factors. And so the 0 x equals 3 has a multiplicity of 1. The 0 x equals minus 2 has a multiplicity of 3. The 0 x equals minus 5 has a multiplicity of 2. And the 0 x equals 1 has a multiplicity of 2. All right. Now, based upon the multiplicities, we know in the graph of this polynomial function, at the x-intercept, whether the graph is just going to touch the x-axis or whether it's going to cross the x-axis. And if the multiplicity is odd, the graph is going to cross the x-axis. If the multiplicity is even, the graph is just going to touch the x-axis. Okay? So, for these first 3 zeros, we know that the graph is going to cross the x-axis, right? Because remember, the zeros are also the locations of the x-intercepts. Okay. And at x equals minus 5 and at x equals 1, right, the multiplicity is 2, which is even. And so the graph is just going to touch the x-axis, right? It's not going to cross the x-axis. Okay. And you can say something like touch and churn. Okay. Now, it turns out that the degree of the polynomial is equal to the degree of this factored polynomial is the sum of the multiplicities. Okay? So we add up all the multiplicities. 3 plus 1 plus 3 plus 2 plus 2 is equal to 11. Okay? So the degree of the polynomial n is equal to 11. Sum of multiplicities, which is also just the sum of these exponents, right? 3 plus 1 plus 3 plus 2 plus 2. Okay. So this polynomial function is a polynomial of degree 11. And the leading coefficient of this polynomial function is minus 1. Right? This number out in front here. So minus 1 is the leading coefficient. And so now we know the leading term of this polynomial function, okay? Because the leading term has the form a times x to the n, okay? A is the leading coefficient, n is the degree of the polynomial. Okay? So this is equal to, in this case, minus 1 times x to the 11th power, okay? Which we might just write as minus the negative of x to the 11th. That's the leading term. Well, from the leading term, we can determine whether the right end of the graph goes up, whether it goes down, whether the left end goes up, or the left end goes down. So with minus 1 times x to the 11th, or the negative x to the 11th, what's going to happen on the right end? Is the graph going to go up, or is it going to go down? It's going to go down. What about the left end? It's going to go up. Okay. So we covered all that on page 1. Okay. That's Friday before spring break. Okay. So now we know the end behavior, and we know the location of the x-intercepts, and we know the multiplicities, so we know where the graph's going to cross or touch at each of the x-intercepts. And so now we can do a crude graph. Sometimes I swear they wait till I start lecturing to do that stuff on the side. Always seems like they're doing it when I'm lecturing. And then they stop when class is over. All right. So you're being provided a x and y axis. And we know the location of the x-intercepts, okay? Now remember, this is just a crude sketch, okay? We're not looking for perfection, but you have to, if this was an exam question, we'd have to get the x-intercepts right, okay? And the end behavior right. So we have minus 2, minus 5, and then we have what? 1, 3, and 4. So here's 1, here's 3, and here's 4. All right, the best I can do. Now, we know the graph goes down on the right end. So from this x-intercept, the last x-intercept on the right, the graph has to go down. And it goes up on the left. So from the last x-intercept on the left, it has to go up. Okay. What happens in between? Okay. Now, the multiplicity at the root x equals minus 5 is even. It's 2. So we know at x equals minus 5, at this x-intercept, the graph touches. It doesn't cross. So the graph has to come down, touch the x-axis, and then turn around. Okay. At x equals minus 2, the multiplicity is odd, and so we know the graph is going to cross the x-axis at minus 2. So it has to come up, form a turning point, and then come back down, and cross the x-axis at minus 2. At x equals 1, the multiplicity is even. So we know the graph touches the x-axis at x equals 1, but it doesn't cross it. So the graph has to come down, form a turning point, come up, touch the x-axis at x equals 1, and then turn. Okay? It doesn't cross the x-axis, it just touches it. Okay? And then at x equals 3, the multiplicity is odd, right? Plus 1. So the graph has to cross the x-axis at x equals 3. So it has to come down, form a turning point, and then come up and cross the x-axis at x equals 3. And then at x equals 4, the multiplicity is odd. So we know the graph crosses the x-axis at x equals 4. And we also know it's going down to the right at x equals 4. So it's got to come up, form a turning point, come back down and cross the x-axis at x equals 4. It's all deductive reasoning, ladies and gentlemen. Okay. A lot of deductive reasoning in mathematics. Okay. And so you would, if this was a test question, I would expect you to get the behavior correctly, and I expect you to get the behavior at the 5x intercepts. Correct. Correct. Okay. Any questions on that? Okay. All right, I think if I recall correctly, this homework assignment has like 16 or 18 questions. I think it's 18 questions, but 16 are multiple choice, where you got to pick the right graph. We actually don't use a graphing tool in web assignment on this homework assignment. It's multiple choice. You have to pick the right graph. All right. So if there are no other questions, let's move on to the next example, bottom of the page. The cubic polynomial p of x has a 0 of multiplicity 1 at x equals 1, a 0 of multiplicity 2 at x equals 2, and the value of the polynomial at x equals minus 1 is equal to 2. Determine p of x, so we got to actually come up with the function p of x and sketch the graph using that information. All right. So let's write out the form of the polynomial function, right? We're given zeros and multiplicity, so we're going to write out the polynomial function in factored form, okay? And so there's an unknown leading coefficient we'll call A out front, okay? And we're given that this cubic polynomial has a 0 of multiplicity 1 at x equals 1. So that means x minus 1 is a factor. And since it has a multiplicity 1, right, the exponent on the factor x minus 1 is plus 1. Okay? But it's invisible too. And then we're told this cubic polynomial has a 0 of multiplicity 2 at x equals 2. So the factor polynomial has x minus 2 squared as a factor. 2 is a 0, and it has a multiplicity of 2. Okay. So technically all we got to do is figure out what A is. And now we'll have this factored polynomial that meets these conditions. Well, we're told that p of minus 1 is equal to 2, right? So let's plug in minus 1 for x over here. And we have p of minus 1 is equal to a times minus 1 minus 1. I'm going to drop, right, leave the exponent, the invisible 1, times minus 1 minus 2 squared. Well, p of minus 1 is equal to 2. So I replaced p of minus 1 with 2, and now we just got to simplify the right-hand side, and then solve for a. Okay. So minus 1 is equal to minus 2. You know PEMDAS, you do parentheses first, right? So, and then minus 1 minus 2 is negative 3, and negative 3 squared is equal to 9. So we have 2 is equal to minus 2 times 9 is negative 18. So we have minus 18a on the right. And now you divide both sides by minus 18. And you get a is equal to 2 over minus 18. Or a is equal to a negative 1/9. So we put minus 1/9 in for a over here. And now we have the factored polynomial p of x. P of x is equal to minus 1/9 times x minus 1 times x minus 2 squared. So that is, right, the cubic polynomial p of x. Okay? It meets all the conditions in the problem. Okay? And now we can graph it. Okay? Now one thing, I did one additional thing in my graph. I calculated the y-intercept. And you know the y-intercept occurs at x equals 0. Okay? And so you put in 0 in for x, and you have minus 1/9 times 0 minus 1 times 0 minus 2 squared. And when you do that arithmetic, I get 4/9. So the y-intercept is y equals 4/9. So now let's graph this then. So we have x-intercepts at x equals 1 and x equals 2. And we have a y-intercept at 4/9. So I'll just briefly label that as 4/9. What we haven't done is determine the end behavior, right? And so what's the leading term? Well, first of all, what's the degree of this polynomial? It's the sum of the multiplicities, right? And the sum of the multiplicities is 1 plus 2, which is 3. So this polynomial, its degree, n, is equal to 1 plus 2, which is equal to 3, right? So it's a third-degree polynomial. And what its leading coefficient? Minus 1/9. So if we were to expand the right-hand side of p of x, the leading term would be minus 1/9 times x cubed would be the leading term. And with an odd degree and a negative leading coefficient, we know the right-hand side goes down and the left-hand side goes up. in behavior. Okay. All right, so here we have x-intercept at x equals 1, 1 at x equals 2. So we know the graph is going to go down from the most right hand, from x equals 2, from the x-intercept x equals 2, right? The x-intercept on the far right. And we know it's going to go up to the left from x equals 1. Okay. Now, the thing is, it's got to cross the y-axis here, so it's going to do something like this. From the x-intercept at x equals 1. It's going to cross the y-axis here, right? So it's going to go from here at x equals 1 and go up and to the left, but it's got to cross the y-axis at 4 nines. Okay. Now, the multiplicity for the 0 x equals 1 is odd, so the graph has to cross the x-axis at x equals 1. The multiplicity for the 0 x equals 2 is even, and so it's got to, after it crosses the x-axis, it's got to come up and touch the x-axis at x equals 2, and then go down. So it's going to form a turning point, come up and touch the x-axis at x equals 2, and then go down again. So any questions on that? All right, one more example. Sketch a graph of the polynomial p of x that has a 0 multiplicity 1 at x equals 1, a 0 multiplicity 2 at x equals minus 1, a 0 multiplicity 3 at x equals minus 3, and satisfies the following conditions. Okay. So p of x is the name of the polynomial function, and so this is saying that as p of x goes to minus, and this says that p of x goes to minus infinity as x goes to plus infinity. Well, this is the x-axis, and so this is saying x is increasing without bounds, so we're talking about right-hand behavior. This is for large positive values of x, and it's saying p of x is going to minus infinity, so this is saying the right end is going to go down. Okay. Right end falls. This says that as x goes to minus infinity, so we're talking about large negative values of x, we're talking about the left end behavior. As x goes to minus infinity, p of x is going to minus infinity. So that means the left end is going down as well. Okay. So both the left end and the right end go down. That's what this is telling us right here. Okay. All right. So for the 0 x equals 1, the multiplicity is 1. At the 0 x equals minus 1, the multiplicity is 2, right? So this is odd, this is even. And 0, for the 0 x equals minus 3, the multiplicity is 3, which is odd. So it has a 0, a multiplicity 1 at x equals 1, a 0, multiplicity 2 at x equals minus 1, and a 0, a multiplicity 3 at x equals minus 3. And it satisfies the end behavior. Okay. Well, so you're provided a coordinate plane, and the zeros are minus 1, plus 1, and minus 3. Okay. Well, we know on the left end the graph goes down. So from this x-intercept farthest to the left, the graph has to go down. And from the x-intercept farthest to the right, the graph has to go down. Okay. What goes on in between? Okay. Well, at minus 3, at x equals minus 3, the multiplicity is odd, so we know the graph crosses the x-axis at x equals minus 3. At x equals minus 1, the multiplicity is even, so we know the graph touches the x-axis, but it doesn't cross the x-axis. So what has to happen is that the graph forms a turning point, and it comes down and it touches the x-axis at x equals minus 1, and then it turns back up again. At x equals 1, the multiplicity is odd, and so the graph has to cross the x-axis at x equals 1. And the graph goes down, so this all makes sense. And that's a crude sketch of this polynomial function, given the information that we have. Okay. Any questions on that, ladies and gentlemen? Okay. So you have everything you need to successfully complete the web assignment homework. So there are 7 copies here for everybody. Did he leave or just step out?
No, he went out to the bathroom.
Okay. Miss in the back, leave and 2 for those 2 ladies. All right. So now we're going to talk about division polynomial functions. Dividing one polynomial function by another. And so sometimes when you divide one polynomial function by another, you got to use long division. You guys learned long division 100 years ago, maybe? Couldn't have been that long ago. somewhere in your K through 12 education, you had to have been introduced to long division. So we're going to learn, right, review how to divide two polynomials using long division, because we have to use that sometimes. And then we're going to learn a special case called synthetic division. And a lot of you probably, right, have been exposed to synthetic division, but you can only use it in a particular case, okay, in a particular instance. So let's review long division with real numbers. So the back page is blank. So what I put on the board, you might want to put on the back page, okay? So 107/3 is what we call, is an example of what we call an improper fraction, okay? And we prefer to work with improper fraction at the college level, right, instead of mixed numbers. It's easy to multiply two improper fractions, rather difficult to multiply two mixed numbers. Okay? Well, this, remember, fraction bars are like division symbols. So this can be read as 107 divided by 3. Okay. Now, so let's divide 107 by 3 using long division as a review, hopefully. So the numerator, 107, goes under the division symbol, okay? And that's called the dividend. And what it's being divided by, the number it's being divided by, goes out here on the left. In this case, 3, 107 is being divided by 3, and that's called the divisor. And you probably know the procedure, right? First, you look at the first digit of the dividend, which is 1, and 3 is less than or is greater than 1, right? 3 goes into 1 0 times. So we skip that. And we look at the first two digits, which is 10, 1 and 0, right? 10, and 3 goes into 10 3 times. So we put 3 above the division symbol, above the 10. And the next step is to multiply 3 times 3, and you get 9. And you subtract 9 from 10, and you get 1, right? So that's the remainder. 1 is the remainder from dividing 10 by 3. And now you bring down the 7. And now you divide 3 into 17, right? How many whole times can you divide 3 into 17? Well, 3 goes into 17 5 times. So you put 5 up here above the 7, and then you multiply 5 times 3, and you get 15. And then you subtract 15 from 17, and you get 2. Okay? So the 2 down here at the bottom is called the remainder. And the 35 up here is called the quotient. Okay? So we divided, right, 107/3 can be thought as 107 divided by 3. And when we divide 107 by 3, right, 107 divided by 3 is equal to 35, okay, with a remainder of 2. So let's write that out. 107/3 is equal to 35, the quotient 35 plus 2/3, right? You take the remainder 2 and divide it by the divisor, okay? Now some of you would write this as a mixed number as 35 and 2/3, right? That's what 35 and 2/3, the mixed number 35 and 2/3 means, 35 plus 2/3, okay? All right, Now if I multiply both sides of this equation by 3, I have 107 on the left, right? 107 divided by 3 times 3 is just equal to 107. Then on the right hand side I have 3 times 35 plus 3 times 2/3, which is 2. Okay. And so from our long division, we can express the number 107 as 3 times 35 plus 2. 107 is the dividend. 3 is the divisor. 35 is the quotient. And 2 is the remainder. Okay? So hopefully this is a little deja vu for you. Okay. Well, now we're going to employ this same tactic in dividing two polynomials. Okay? And as I said, a lot of times when you divide two polynomials, you have to use long division. Okay? Synthetic division only works in a special case. So in example 1, right, and we're going to divide we have 2 examples we're going to work. In the first case, right, we're going to divide this 3rd degree polynomial by the 1 degree polynomial x minus 2. Okay, the linear polynomial x minus 2. So, just to emphasize a point, dividing that 3rd degree polynomial by the linear polynomial x minus 2. Again, fraction bars are like division symbols. You can think of this quotient as this 3rd degree polynomial in parentheses divided by that linear polynomial x minus 2. Okay. All right. So to divide the numerator by the denominator, we do the same setup as we did with the real numbers. X minus 2 is the divisor, and 6x cubed minus 19x squared plus 16x minus 4 is the dividend. All right. Now, when you write out the dividend, always write it out in descending powers of x. When you write out the divisor, write it out in descending powers of x. And so the first question we have to ask, right, so the leading term for our dividend is 6x cubed, and the leading term for our divisor is x. So the first question you got to ask is, how many times does x go into 6x cubed? Well, 6x cubed divided by x is equal to, using the rules of exponents, x cubed divided by x is x squared. So 6x cubed goes, so x goes into 6x cubed, 6x squared times. So under the term up here with x squared, we put 6x squared. Correct. I said that wrong. Above. Sorry about that. Right. I'm doing like we did with real numbers. right? X goes into 6x cubed, 6x squared times, right? So I put it above the term in the dividend with x squared. Okay. And now, like we did with real numbers, you multiply 6x squared times the divisor, and that's what we're going to subtract from the dividend. Okay. Just like we did with real numbers. So 6x squared times x minus 2. When you distribute the 6x squared, you have 6x squared times x, which is 6x cubed. And then 6x squared times minus 2 is minus 12x squared. So 6x squared times x minus 2 is equal to 6x cubed minus 12x squared. And we're going to subtract that binomial from the dividend. You got to put it in parentheses, because we're going to subtract both terms, not just the first term. Okay. Well, when I distribute the minus sign inside parentheses, I have minus 6x cubed, and 6x cubed minus 6x cubed is 0. That's what we want to get. Minus 19x squared plus 12x squared, right? We're at minus 12, which is plus 12. Minus 19 plus 12 is negative 7. So the remainder is minus 7x squared from that first step. You follow me? Now we bring down the 16x minus 4. And now you got to do with this quadratic, these three terms here, right, divided by x minus 2. So you got to ask yourself, how many times does x go into minus 7x squared? Minus 7x squared divided by x is equal to minus 7x, right? X squared over x is x. So x goes into minus 7x squared minus 7x times, right? So I write minus 7x above this term here in the dividend. And now I got to multiply minus 7x times x minus 2 and subtract that from this quadratic. So minus 7x times x minus 2. Distribute the minus 7x. You get minus 7x squared plus 14x. So we're going to subtract, in parentheses, minus 7x squared plus 14x. All right, we're doing the same steps that we did with real numbers, but now we're multiplying, doing it with polynomials, right? Terms of a polynomial. And math is more complicated. Okay. Well, now when I distribute the minus sign, minus 7x squared becomes plus 7x squared, and plus 7x squared minus 7x squared is 0. You want that to go away, right? The term with x squared has to go away, or you did something wrong. Plus 14x becomes minus 14x, and 16 minus 14 is 2. So we're left with 2x, and then we bring down to minus 4. We're almost done. Now you gotta ask yourself, how many times does x go into 2x? Well, 2x divided by x is 2. So x goes into 2x twice. I can write it over here. 2x divided by x is 2, right? X goes into 2x twice, and then you gotta multiply 2 times the divisor, x minus 2, and you get 2x minus 4. So x goes into 2x twice, and so we have 2 times, now we're going to multiply 2 times x minus 2, which is 2x minus 4. You got to subtract 2x minus 4 from 2x minus 4. Put it in parentheses, or you'll only subtract the first term. And you can see 2x minus 4 minus itself is 0. And so the remainder for this example is 0. And when you're dividing polynomials, the remainder would typically be a function of x. So the remainder, r of x, is equal to 0. And the quotient is a function of x, called q of x. And the dividend which is just the name of the function, okay? In this case is f of x. And the divisor, we typically use b of x to represent the divisor, right? All 4 of those, the quotient, the divisor, the dividend, the remainder, right, are functions of x when you're dividing polynomials. Okay. All right. So what we have shown is that our original polynomial function in the numerator, 6x cubed minus 19x squared plus 16x minus 4 can be written as the product x minus 2 times this quotient. So in this case, since the remainder is 0, x minus 2 is a factor of our third degree polynomial, right? Our third degree polynomial can be factored into x minus 2 times this quadratic. Okay. Any questions on that, ladies and gentlemen? You'll get practice with the web assigned homework and the quizzes and the exams, blah, blah, blah. But, right, you can, right, synthetic division is wonderful when you can use it, but you can't always use it. Okay? Sometimes you got to do it the old-fashioned, right, dividing two polynomials. All right, so there are no questions. Let's look at the next example. We should be able to speed things up now that you got a taste of this. So we're going to divide this 5th degree polynomial function by the 2nd degree polynomial function, right? Degree 5, degree 2. Okay. So the divisor is x squared minus 3. The dividend is 2x to the 5th And you notice that there's no x to the fourth term, right? These are written descending powers of x, but there's no x to the fourth part. It's actually 0 times x to the fourth, right? The coefficient for x to the fourth is 0. And so you can either pad a 0, right? Write it as 0 times x to the fourth, or just leave it blank. Okay. So usually we just leave it blank. And for the space for x to the fourth. And then we have 4x cubed minus 5x squared plus 3x minus 2. So again, x squared minus 3 is the divisor, and this fifth degree polynomial is the dividend. How many times does x squared go into 2x to the fifth? Two x cubed times. So we put 2x cubed here. And then we multiply 2x cubed times the divisor, x squared minus 3. And when you distribute the 2x cubed, you get 2x to the fifth minus 6x cubed. So we're going to subtract 2x to the fifth minus 6x cubed. So when I distribute the minus sign, I have minus 2x to the fifth plus 2x to the fifth, which is 0, which is what you want to get. Minus 6x cubed becomes plus 6x cubed, and plus 6 plus 4 is 10. So we get plus 10x cubed. Then we bring down the rest of the dividend. You got to ask yourself, how many times does x squared go into 10x cubed? 10x cubed divided by x squared is equal to 10x. So x squared goes into 10x cubed 10x times. And now you got to multiply. Let's see, what is that? Plus 10x. So the plus 10x goes here. And now you got to multiply plus 10x by the divisor. So 10x times x squared minus 3, which is equal to 10x cubed minus 30x. A lot of algebra, right? This is the kind of stuff you got to be good at when you take Calc 1. Okay? A lot of algebra in Calc 1. Okay? So 10x times x squared minus 3 is equal to 10x cubed minus 30x. And we're subtracting that, right, from this third degree polynomial. And when you distribute the minus sign, you end up with minus 10x cubed plus 10x cubed, which is 0, which is what you want. And then we have 0 minus 5x squared plus 0, which is minus 5x squared. Minus 30x becomes plus 30x. 30 plus 3 is 33. We're almost done. Now you gotta ask yourself, how many times does x squared go into minus 5x squared? Well, minus 5x squared divided by x squared is minus 5. So x squared goes into minus 5x squared minus 5 times. And you're going to multiply minus 5 by the divisor, x squared minus 3. So when you distribute the minus 5, you end up with minus 5x squared plus 15. So you got to subtract minus 5x squared plus 15 from that quadratic right here. So when you distribute the minus sign, minus 5x squared becomes plus 5x squared, plus 5x squared minus 5x squared is 0, which is what you want. This is 0x. 0x plus 33x is 33x. Plus 15 becomes minus 15, minus 2 minus 15, minus 17. Well, x, you can't do any more division because x squared goes into 33x 0 times. Okay. So this is the remainder down here. This is the quotient, q of x, and this is the divisor d of x. So, we have just shown that our 5th degree polynomial, 2x to the 5th plus 4x cubed minus 5x squared plus 3x minus 2 is equal to the divisor, x squared minus 3, times the quotient, 2x cubed plus 10x minus 5 plus the remainder, 33x minus 17. So our 5th degree polynomial in the numerator of that quotient on the screen divided by the quadratic x squared minus 3 can be written as x squared minus 3 times 2x cubed plus 10x minus 5 plus the remainder, 33x minus 17. Okay. Classic example of this, said you could not do synthetic division. Any questions on this? So tomorrow we'll do the synthetic division.